So let's do it here. So we're going to, of course, get into rotations. We've already done, just to review, translations, up, down, left, right. We did reflections was 4.2, and now we're in rotations. So as always, a little bit of vocab here we have to fill in at the very top. Let's kick it off with that. So a rotation is a transformation. Those are the first two words you got to fill in. And what you figure is turn about a fixed point called the center of rotation. Rays drawn from the center of rotation to a point and its image form the angle of rotation. So that's everything you have to fill in on the blank. So let me give you a minute to do that. And then you can see on the rest of the note page, really it's just the formulas. There's not a whole lot on there. But let's talk about the formulas. So, as always, I wish we had color copy machines, because you can see, I think it's easier to see up here, my blue triangle is rotated onto the red triangle by 40 degrees. That's what we're going to be doing today, is rotating the images around the graph grid. Now, there's an example of 40 degrees. And obviously you can rotate things 40 degrees. We are going to keep it simple, and we're going to be working on 90, 180, and 270. So that is the next thing. I also want to point out one thing, because you're going to see one little twist on our problem today. So at the bottom, a 40-degree counterclockwise. So hopefully we know which way counterclockwise is shown at the right. Rotations can be clockwise or counterclockwise. In this chapter, all rotations are counterclockwise. So, even if it doesn't say, I can't believe I'm going to say this in here because I said I never did this, you can assume they're counterclockwise. And that's what all of our formulas on the sheet are geared towards, counterclockwise. So again, counterclockwise is going this direction around. Clockwise, just for the thrill of knowledge, would be going this way. We're going to be going counterclockwise around our graph grid today, just for the record. And I might have one little fun little spicy twist for you. So like I said, you do not have to have this formulas memorized. Clearly, we just saw an example of a 40-degree rotation. We're going to keep it easy with 90, 180, 270. So here's our starting point. Mine's in blue up here. If we're going to rotate 90 degrees, here's what happens to the ordered pairs. Now you can see there's some negative signs on these. I kind of like to think of that more so as the opposite. So let's say B was -5, you're going to use +5. Or if B was, let's say, I don't know, 8, you would use -8. So I kind of think of the negative sign in the formula more so as the opposite. So sometimes that can kind of trip kids up. So just be conscientious of that. So for 90 degrees, you have to reverse the order and B gets the negative. 180, you can see 180 here, my green colored that, I guess. You can see super easy, order stays the same, you just switch the signs. Easy. 270, you reverse the order, but now A gets the negative. So again, you'll have the formulas, just be very conscientious on if you keep the order, switch the signs, 180, switch the order, change the sign on B, or switch the order, change the sign on A. You just have to read closely. This is as wild as it gets today. So here we go. Graph the quadrilateral. All right, start graphing. R is at 3, 1. And again, on any quiz or test, it's always going to tell you, of course, to label. Let's make sure our phones are away, please. And then 5, 1. And then T5, -3. And U at 2, -1. And I'm just going to connect it. Hopefully you draw nicer than I do. Now, we are rotating it 180 degrees. I do sometimes have kids that can look at that figure and spin it half of a circle and mark it out. I am not that good, okay? So I'm going to use the formula. So 180 degrees up here on the board, order of the coordinates stay the same. They both have negatives. I'm just going to switch the signs. Okay, all right, I got it. So R prime. Same order, I just switched the sign. So it's going to be -3, -1. Then I'm going to do S prime. Order stays the same, I just changed the sign. So -5, -1. And then let's see what else we got. T prime. Again, Keep the order, change the signs. -5, +3. And of course, u prime, -2, +1. So I'm going to go ahead and mark those. We got to be good at writing ordered pairs too, because sometimes they will ask you for that. So r -3, -1, r prime, -5, -1, -5, 3, and then -2, 1. I'm just going to connect it. So, like I said, I have some kids, I think this is hard personally to do in your head. They can take this red figure and recognize again, we're rotating it, of course, counterclockwise this direction. They can spin it half a circle and land there and mark it. I'm not that good. I can't match it up. It makes me nervous. I always like to use the formulas. And like I said, sometimes I do ask you for the ordered pairs on the formulas. Okay. So any questions on marking that guy out? All right, too easy. Let's do the next one then. Graph the triangle. All right, start plotting your triangle. A is -3, 2. B 2, 4. And C 3, 1. And as always, make sure you label. Rotate it 90 degrees counterclockwise. Now, like I said, I have to use the formula. So here we go. This is a little trickier formula. Notice the ordered pair reverses slots, okay? And the second coordinate, the B, you're switching the sign on. So here we go, A prime. I'm going to switch the order, and before I write it down, I'm going to change the sign on the second coordinate. So it's going to be -2, -3. B prime, same deal. I'm going to switch the order, but I have to change the sign on 4. So -4, +2. And C prime. Switch the order, but you have to change the sign on 1. So -1, 3. And of course, I'm just going to plot it and draw it. So -2, -3. -4, 2. -1, 3. Now, again, more power to you. I'm actually kind of jealous if you can do these in your head. If you take the purple triangle and you spin it 90 degrees, it will land on the green. I'm not good enough to just visually see it. I have to write out the ordered pairs for it. Any questions on that guy? All right, too easy. 2 more graphs to do and a little vocab chat and we're done. All right, graph the triangle. Okay, here we go. Graph the triangle. 1, 3, 4. And 1, 1. Got it. Let me give you a second to mark your triangle out here. And then super fun chat, 90 degrees clockwise. Here it comes. All our formulas, remember, are for counterclockwise. So we gotta be smart, we can still do it. So 90 degrees clockwise, of course, would be this way. Now, we don't have formulas for clockwise, so I gotta be smart. Of course, I can spin it, I can come the other direction and land here. But the question is, how many degrees is this going to be? To figure it out, easy question, how many degrees in a circle? Full circle. 360, Jordan says she's right. So what I'm going to do is I'm going to do 360 degrees. I'm not going to write in yellow because it doesn't show up the best. And take off the 90. That lands you in the same spot. So I'm going to erase all this stuff I marked on here to kind of help us figure that out. And this is part of a triangle. Let's get him back on there. And now I'm going to use the formula over there for 270. This is the only trickster of the day, my friends. So, of course, you have to switch the order. No big deal there. And notice you have to change the sign on the first coordinate. All right, we can do that. So, D prime. I'm going to change the order, switch the sign on the first coordinate. So I'm going to have +1, -3. All right, E prime. Same thing, I'm going to switch the order, and I'm going to change the sign on the first value. So I'm going to make it +4, -3. And F prime. Change the order. Oh, so one. But we're going to switch the sign, of course, on the first term there. So I'm going to make it +1, -A. Let's plot it, draw. All right, 1, -3, D prime, 3, 4, 1, 2, 3. Pretty good on my yellow mark there. I didn't erase that. That's where we landed. And F prime. And I'm like, oh, okay, yeah, okay. Now I see it. If I rotate it 90 degrees clockwise, we land there. 270 degrees counterclockwise also lands it there. That is the only tricky thing of the entire day. That's all you got. Last things review. We got some vocab. Now, we're going to do again of course, glide, reflection. Remember, this common sense goes in order. Do the translation first and then the reflection. Do not skip to the end. We have to do all of these. So let's plot it, of course. Graph the segment RS. R is at 1, -3, and then 2, -6. I'm just going to label them. Now, first up, I'm going to color code it. We're going to do the translation. 180 degrees about the origin. So here we go, 180. Same order, we don't have to worry about changing any order, we just switch the signs on the ordered pairs. So R prime, we're going to change the signs, we're going to make it -1, +3. And then of course S prime, I'm going to make that -2, +6. Plot that, make the segment, equal the deal here. Might help if I connect this first one though. All right, -1, 3. R prime, S prime. Okay, we got it. All right, next up, one at a time. I'm going to do this one in blue. Reflection in the y-axis. So here's a throwback to 4.2. We're just going to practice that. So y-axis, of course, my vertical one. I'm just going to dot it in. Now, reflecting. The green one, where I left off, I want to reflect it over that blue dashed line. So remember, reflection is just the straight up counting. I'm going to start here at R. I'm 1 to the left of the blue line, so I put it 1 to the right. Double prime. Fancy. Okay, S. I'm 2 on the left of the line, so now I'm going to go straight across 2 to the right. Got it. So the blue segment is your final answer. Just for the record. Any questions there? All right, vocab time. Have any of our pictures changed sizes? No, not yet. I swear we talk about it every day. Just vocabulary. Remember, it will change size eventually. We call that an isometry. We call that a congruence transformation. Good vocab, good vocab. Sometimes you'll also see it called a rigid motion. Just for the record, just know that's really the only vocab you have to know this chapter. Isometry, rigid motion, congruence, transformation. All means the same thing, they don't change that. All right, the last thing I have for you, this is one of these things you have to picture in your head. Rotational symmetry. So you want to be able to rotate the picture around and have it land and make the exact same picture. So a figure in the plane has rotational symmetry, can be mapped onto itself, here's the key, by a rotation of 180 or less. If you go beyond 180, because you can have rotational symmetry over 180, but we don't need the answers, we're only going up to 180. This point's called the center of rotation. Notice the rotation can be clockwise or counterclockwise. So if you look at the picture, here's the starting one. So clearly they're showing you 45 degrees wouldn't work on that, because if you spin it 45, it's not the same picture. But they took it, they spun it 90 degrees, they spun it 180, and you do end up with the beginning original picture. So this, of course, we would say has a rotational symmetry of 90 and 180. So, of course, like we said, anything up to 180 is as far as you need. So like here, just catch this note, that's what it's saying. Figure has rotational symmetry, we list every multiple up to and including 180. So if it's 30, you're going to list 30, 60, 90, 120, keep adding 30, 150, 180, and you can stop at 180. All right, let's look at the picture, see what we can do. Does the figure have rotational symmetry? If so, describe, let's do it in purple. Describe any rotations that match it onto itself. Well, I'm going to tell you this does have rotational symmetry. The question is, either direction, how many degrees would I have to spin it to have it be the exact same picture? I heard it, 180. 180. If you rotated a half circle, and I don't have to go any further than that. All right, B. B's kind of an easy one because of this key word. Regular means you have the same length on all the sides. They're all congruent, and all the angles are congruent. Now, octagon. How many sides on an octagon? 8. So I can make my life really easy on this one if I'm like, oh gosh, I'm not great at picturing it. I'm just going to take my full circle and cut it evenly by 8. So of course in my calculator, punch that in, or we just know it maybe. Every 45 degrees, it will map onto itself. So every time I spin this 45, it's going to be the same picture. Now I have to list out all those angles. So 45 obviously. I'm going to add another 45. I'm going to add another 45. I'm going to add another 45. And now I'm going to stop because we only have to go up to 180. All right, what do we think about C of that trapezoid? There is rotational symmetry, kind of, sort of, maybe, but you would have to spin that thing a full circle to get it back to map on itself. A full 360. What's our limit? So we're going to say a big fat no. Because we would have to do a full 360 degree spin to get it to map onto itself. We only got to go to 180. So that is, I think, this is the tricky part of the lesson, is being able to picture that or figure out how much you can rotate it to map onto itself.